Hello, everybody, and welcome back to week 4 of RobotGo. In this week's video, we're going to talk about motors, and we're going to talk about running them at a constant speed, and we're going to talk about running them at a variable speed, meaning the speed of the motor changes with some input, rather than constant speed where they just kind of run at a single speed for the whole time. So I know that I wrote drivetrains here, but in the week 4 class, we didn't actually get to these. So I'm going to reserve discussion of drivetrains for the week 5 video. But that being said, let's get into it. So what we did last week in week 3, in the week 3 video, was we talked about hardware and we gave an introduction to the hardware. So we talked about some of the basic hardware pieces we'll need, including our control hub, our expansion hub, which kind of act as like the brains of the robot, the driver station, which is the app on the phone that you, the driver, will use, and the gamepad, which is essentially the game controller that we use to control the robot. We also went over some sample code for the gamepad, and we talked about how to find the class definition for the gamepad, the structure of a linear op mode, which is the type of op mode that we'll be using to code, and we also talked about telemetry. Now, the week 3 video is actually available on YouTube, so if you want to watch that now, it's there for you to see. So today what we're going to talk about, like I said, is we're going to talk about motors. Motors are one of the most important pieces of hardware you guys are going to need. Without motors, you guys are unable to, drive, you're unable to run any of your intake mechanisms. I mean, the motors are very useful. You need them for a lot of things. So we're going to talk about motors in a teleop sense today, meaning how do we run them as a driver at a constant speed and how do we run them at a variable speed? So what we're going to do is we're going to look at some sample code, or actually we're going to write code together, excuse me. We're going to write some code together to run the motors at a constant speed. And then we're going to look at an example of running the motors at a variable speed. So if you guys want to pull up Android Studios as you're watching this video and code along with me, I think that'll be very beneficial. I'd highly recommend that. So with that being said, what we're going to do is we're going to transition to making our piece of code. Now, this is actually what we wrote in class, but I'm going to write it again here just so you guys can follow along with me. So in order to create a new piece of code, or an op mode, essentially, the first thing you need to do is you need to go to this left bar here in Android Studios and notice that I'm on my branch, Rohan branch. And to create a new file, you're going to go to team code, Java, and then this org first inspires FTC team code. And to create a new op mode, you're going to right click on this, what I have highlighted in blue. You're going to do new, and you're going to do Java class. Now this will create a new op mode for you. And what you can do is you can name this whatever you want. So I'm going to call it week 4 motor or constant motor code. And you want to click class here or double click it. So I'm going to double click class. And what that'll do is in the folder, it will create a brand new class, Java class called week 4 constant, motor code. Now, if you've done this right, what you should see is you should see this package statement at the top. You don't want to touch the package statement. You can just leave that as is. And you should see your class right here, week 4 constant motor code. Now, the first thing that we're going to do is we actually need to make this a linear op mode. Right now, it's just a regular, ordinary Java class. In order to make it a linear op mode, we're going to type extends linear op mode. Okay? And what that's going to do is it's going to actually come up right here in Android Studios. You see Android Studios brought this. And when I double click this, it will automatically import the library I need for the linear op mode. This is something that's going to happen a lot when you're coding. Android Studios is a very helpful tool. And one of the best things it does is it automatically imports the specific libraries and classes that you'll need. Otherwise, you have to do it yourself. So when Android Studios suggests something that you need, I would suggest clicking it because it will set it up for you. Now, right here, you can see that this is red. So it looks like we have an error. But what's going on? So if you just hover your mouse over this red line, it will actually tell you what's going on. So basically what it's saying is that you need to class week 4 constant motor code must either be declared abstract or implement abstract method run op mode. Now, this is a little bit too complicated, so I'm going to dumb it down for you. Essentially, what happens is when you make a linear op mode, which is the type of program that you'll be running on your robot, a linear op mode has a rule. And the rule is that there is a method called run op mode that you have to implement. You have to implement it, otherwise it's not a linear op mode. That's the rule. Now, if you want to learn more about why that's the rule, you can look into something called abstract classes. Now, this is purely optional. You don't really need to understand it. But for the sake of simplicity, the rule is that if you're using a linear op mode, you must have this run op mode method declared. Now, Android Studios, once again, is helping us because what it will do is you can actually click. So if I hover over this, you see this button right here, implement methods. So if I click this, it will show me the method that I need to declare, which is run op mode. And what I can do is I can just click OK, and it will automatically bring in the method for me. And you can see that the red line has gone away. So all of the code that we're going to write, or most of the code we're going to write, is going to be within this run op mode method. Now, right here, this is your very basic boilerplate code. What we're going to do now is we're going to solve a specific problem. This is the exercise we're going to do to learn how to code a motor at constant speed. And what we're going to do is we're going to solve this very simple problem, which is this. So I'm going to write our problem statement. Essentially, I'm writing what this program we're writing, what this op mode we're writing is going to do. So here is our problem statement. We want to be able to run the motor at different constant speeds based on buttons we press on the gamepad. Now, what does that mean? It basically means that if I press the A button, I want the motor to run at 0.25 speed. If I press the B button, I want the motor to run at 0.5 speed. X button, 0.75 speed, and the Y button, full power. So we are going to make an op mode that does essentially this. And in doing so, you guys are going to learn how to combine the gamepad code from last week with motors from this week. So in order to do this, in order to solve this problem, the very first thing we're going to do is we're going to initialize our motor. So step one, down here, initialize our motor. So what does that look like? Well, we're going to declare a motor variable. And what we're going to do is we're going to make it private. So private DC motor. And you can see Android Studios is recommending that I use this DC motor. So if I double click this, it'll import it for me. Private DC motor, we'll call it my motor, and we're going to make it null. What we've done now is we have declared our motor variable, and we'll use this motor variable throughout the code. This will be the motor that we run at the different speeds. And the reason why I initialize it to null is because we don't actually have a value for it yet. We're about to, and we're just telling Java, okay, we have this variable called my motor. We don't have anything for it yet, but we're going to give it something, so hold on. So right here, we've declared our motor, my motor. The next thing we're going to do is we're going to move inside of run op mode. And generally what you want to do is any variables that you have, you want to declare here, right? Any variables that you're going to be using. So we're going to be using a motor, so we're going to put the motor right here. Now, the next thing we're going to do is we're going to do some basic telemetry just to start. So we are going to have an initialization statement for our telemetry. Now, if you guys don't remember, telemetry is basically like information that we can get back from the robot to us. Think of it almost like debugging statements. It's a way to help us debug what's going on. So what I like to do is I like to put a little telemetry statement right here, just to let me know that I have initialized the robot. So once again, in order to use telemetry, if you guys remember from last week, you have to call this telemetry object. And what you do is within add data, you add anything that you want. So in this case, I'm going to put two statements right here, status initialized. And what will happen is that when I press the init button on my driver station, this piece of telemetry will appear just to let me know that the telemetry has been initialized and that my op mode has been initialized. Now, remember, telemetry kind of works like an essay that you're writing. Think of telemetry as an essay and that you have to print. So whenever you add data to the telemetry, think of it like adding sentences to your essay. And then once you're ready to print your essay, once you're finished with it, you print it out. And that's kind of like what update does. So whatever you want to add to your telemetry, you add using add data. And then once you're ready to put it on the phone screen, you call update. And anything that you've added will appear on the phone screen. So it's a two-step process. We add and then we update. Now that we've done that, step three is we are going to add our motor to our config map. Now, what does that mean? A config map is a special file on the driver station that basically links the software and the hardware together. So right now I have this motor called my motor. Now my motor is nothing. It is just a variable in the code. But ultimately what we want is we want for my motor to be tied to a specific physical motor on our robot. The way we do that, this tying of the hardware and the software together, is through the config map. It links the two together. So the way we're going to do this with the config map is we're going to take this variable that I made, my motor, which was null previously, and we're going to give it an actual value. So what we're going to do is we're going to call our hardware map like this, .get, that's the method we want, and we are going to first pass in the type of the variable that I'm using. So in this case, because my motor is a DC motor, I put DC motor.class. The next thing we need to do is we need to put the name of the motor as we want it to appear on the phone or in our config map. So the convention is that you keep it the same as the variable. So one more time, what this line does is it is essentially linking a variable in the code, my motor, which represents a DC motor, and it's going to link it to a physical motor on the robot. Now, this hardware map is a two-step process. The first step is what we just did in the code. The second step is going to be on the phone, the driver station itself. You will actually say, like, okay, for port 0 of the control hub, which is, say, the front left motor, I'm going to link it to the my motor variable. So it's a two-step process. The first step is here. We're adding it to our config map. That's this. And the second step is on the driver station itself. You will then map this variable to a physical motor. And this is the same process that you do for any piece of hardware, not just motors. Sensors, servo motors, stepper motors, any piece of hardware in the code, you have to add it to the config map for it to be available on the driver station. Now, once we've done that, the next thing we're going to do is we're going to set the direction of our motor. Now, our motors can spin, set direction. Now, our motors can spin either forwards or backwards. In our case, we wanted to spin forwards. So what I'm going to do is I'm going to use my motor variable, and we're going to call a method set direction right here. And when I double click this, I can have this method right here. And because Android Studios is very smart, I could just type in the word forward, and it will automatically, maybe if I do all caps, set direction, a DC motor. Here we go. See, aha, direction.forward or direction.reverse. So all I have to do is double click direction.forward, and it will automatically show up and fill in this path for me. So this is how you set the motor to run forwards. If you wanted to set it in reverse, you would just make this reverse. But in our case, we want it to be forward, so I'm going to put forward. So that's step 4. And step 5 is we need to add our wait for start. Now, what is wait for start? Think of wait for start as a wall. And basically, after you press the init button on the phone, it will turn from init to a play button. That play button is our start button. No code will run after this wait for start until that button is pressed. Once you press that button, the wall goes away, and all of the code you want to run runs afterwards. Now, why is this helpful? It's helpful because when you're there on the field and you press init, there's some code that you might want to run before you actually start the match. That's all of this code right here. Generally, any initialization code you need, like hardware map, telemetry, setting motor directions, and all of that you do before the match starts. Once the match begins, once you press that start button, the actual code that you want to run for the match, like your driving code or your sensor code or your intake code, all of that should happen after the start button is pressed, not before. So wait for start acts like a wall, and any code that you want to run during the match itself will run after this wait for start is pressed. So now that we're here, step 6 is our while loop. And basically, like I was saying, any code you want to run during the match runs in this while loop. Now, the while loop we're going to write is while op mode is active. Now, what does that mean? It basically means that all the code that you want to run during the match. So I'll put a comment here. This code runs after the play button is pressed. So all the code that you want to run after the play button is pressed. Basically, once the match begins, that code goes in here. And op mode is active is basically checking every time the while loop runs. Okay, is the op mode still active? Is the op mode still active? Is the op mode still active? Once you press the stop button and you stop the match, then this while loop will exit because the op mode is no longer active. So now that we're here, we can go back to our problem statement, which is like, okay, how do we do this? How do we, based on different buttons on the gamepad, set the motor to different speeds? So the first thing we need is we need a way detect the button presses. So the way we can do that is we can assign the buttons on the gamepad to certain variables. So I'm going to make a Boolean here called a button pressed, and I'm going to set it to gamepad1 dot a. And what this is doing is basically every time the while loop runs, it's going to check the value of the a button on the gamepad 1. Has it been pressed or has it not been pressed? And if you'll recall, these buttons can either be true or false. So every time the while loop runs, it's going to check the status of the gamepad, the button. And it's basically going to say, okay, if the button has been pressed, it's going to be true. This variable is going to be true. If the button has not been pressed, it's going to be false. And it's going to do that every time the loop runs. We can repeat the same piece of code for all of our buttons, because remember, we're checking for 4 of them. A, B, X, and Y. So what I'm going to do is I'm now going to make this B, make this X, and make this Y. And I'm going to assign each of these to its corresponding button on the gamepad. So this is the B button, this is the X button, and this is the Y button. So now what I'm doing is every time the while loop runs, remember it's a loop, and it's going to keep looping while the op mode is active. Every time this while loop runs, it's basically going to detect the different buttons. And it's going to see, okay, which ones have been pressed and which ones haven't been pressed. And depending on whether it's been pressed or not, these variables are either going to be true, which means it is pressed, or false, which means it's not pressed. Once we have the actual values of the buttons, the next step is basically figuring out, okay, if a button is pressed, we run the motors. So what we can do is we can do a very simple if loop, if statement. So if a button pressed is equal to true, this basically means, okay, if the a button has been pressed, if the user is currently pressing it, then what we're going to do is we're going to set the speed of the motor, which we can do with set power, to 0.25, which is exactly what we want to do here. Now, a quick clarification. When I say set power to 0.25, I'm not saying the motor should run at like 0.25 miles per hour. What this means is I'm basically saying that I want to run the motor at a quarter of its full speed. Or yeah, so quarter speed, essentially. 0.5 means run at half speed. 0.75 means run at 3/4 speed. And 1 means run at your full speed. So what I'm telling it here is run at 0.2 at 25% of your full speed. That's essentially what this means. So if the A button is pressed, I want the motor to be set to this point. I want it to run at quarter speed. Now, similarly, I can also check if the B button has been pressed. So if I can actually just copy this statement. So instead of the A button being pressed, if instead the B button is pressed, I want my motor to run not at quarter speed, but at half speed. So I can change this to run at half speed. I can actually copy this and check the other cases as well. So I can check, like, if the X button is pressed, I can run it at 0.75 speed, at 3/4 speed. And if the Y button is pressed, I should run this at full speed. And if nothing is pressed, if no button is being pressed, I'll just set the motor to run at 0 speed, essentially be off. So 0.0. So just to recap this loop, what this loop is doing is it's first checking to see if the op mode is active, meaning is the match like going on? Has the match been started? Are you competing in the teleop portion of the match? And if it is active, we are going to get the values of the different buttons on the gamepad. If a button is pressed, it is going to be true, and this variable will be true. If it is not pressed, it'll be false, and this variable will be false. In this if-else statement, we are checking every time the loop runs, okay, is the A button pressed? If it is pressed, we're going to set the motor to run at a quarter of its total power. Instead, if the B button is pressed, we're going to set it to run at half of its full power. And then same for 3/4 and same for full power. Now we're almost there. The final thing we're going to do is we are going to add some telemetry, just so we can see as the person running this op mode, okay, is it doing what I want it to do? So the final step is deliver telemetry to the phone. And the way we're going to do that is, remember the essay example, right? We're going to add our data to the telemetry, essentially what we want to see. And what we can do is we can say, okay, I want the A button, and I want to show A button pressed. The way it shows up actually on the phone is it'll look something like this: A button, and then either true if the A button is pressed, or it will look like A button false if the button is not pressed. This is how it will actually appear on the phone, depending on whether the button is pressed or not. And again, we can copy this exact same statement for the B button, the X button, and the Y button. So I'll do that really quick. B, X, Y. And same here. B. So B, X, and Y. And then once I've added all of this to my telemetry, I have to update it. And then once I update it, it shows up on the phone. So I'll put another comment here as well. Shows up on. Okay, and that's pretty much the entire program. That's it. Just a quick recap. We started by initializing our motor, the actual motor we want to run. We put this initial telemetry statement here, just so we know that we initialize our op mode. We added the motor to the config map so that it can show up on the phone when we set our config map in our driver station. We then set the direction of the motor to spin forward. We then have this wait for start statement here. And remember, it acts like a wall. So until you press the start button or start the match, nothing here will run, right? All of this is blocked off. Once you start the match, once you press the play button, the rest of the code runs here. Our while loop is constantly checking if the op mode is still active, meaning is the match still going on. If it is, we're going to grab the value of the gamepad buttons, A, B, X, and Y. If they're pressed, these variables here are going to be true, otherwise they're going to be false. And then depending on whether the buttons are pressed or not, we're going to set the motor to a different speed. So to put it in English terms, if the A button is pressed, run the motor at quarter speed. Similarly, if the B button is pressed, run it at half speed, 3/4 speed, full speed, or if nothing is pressed, turn the motor off. And then finally, we take our data from here and we send it to the telemetry on the phone. Now, the last thing we're going to cover today is we're going to cover variable speed. See, this is an example of running the motor at constant speed because we just set the motor to run at a number, a constant number, 0.25, and then it just runs. Variable speed is different. With variable speed, it starts, you'll notice it starts pretty much the same way. We set up our motor the same way as before. We do our telemetry, add the hardware map, set the direction, wait for the start. But where it differs is in the while loop. What we do is we declare this variable, myMotorPower. And then what we do is we declare another variable called drivePower. Now notice that these are doubles, meaning they're going to hold decimal values. And what we're doing is we're setting drivePower to be the value of the left joystick of the gamepad. Now, if you'll remember, the joystick of the gamepad can go from -1 to 1. Right? That's the speed it can run at. Or those are the values it can be. So it can be any decimal between 1 and -1. Now, the reason I'm negating it here is because for some reason on the gamepad, if you move the joystick up, that counts as a -1 as opposed to positive. So I'm just flipping it here with the negative sign in the front so that it makes more sense intuitively. Moving the joystick forward makes the robot move forward, increases its speed rather than decreasing it. And then once I have this drive power, I'm adding this range.clip. And essentially what this does is it bounds it between -1 and 1. The reason why we bound it is because sometimes what will happen is some errors can occur where this speed might actually be like 1.2 or -1.1. And that can cause unexpected behavior. So we're bounding it to -1 and 1 just to make sure it stays within the range we want. Once I have this my motor power, which is a value between 1 and -1, I send that to my motor. See the same set power variables before? And then I show that here in the telemetry. And now what's going to happen is the speed of the motor is going to vary based on how I move the joystick. If I move the joystick only a little bit, it might run at 10% speed. If I throw it all the way forward, it's going to run at full speed. If I throw it all the way backward, it's going to run at backward speed. So this is an example of running at variable speed because the speed of the motor varies with the value I give it on the joystick, as opposed to here, where I'm just keeping it at a constant speed. So that's everything I wanted to cover today. Thank you so much for listening. Next week, we're going to go over how to run the motor on its own, essentially autonomously, so that you don't need to be there with like a joystick or a gamepad controlling it. And we're also going to talk about drivetrains, which are essentially taking this from a single motor to a group of motors that can actually move your robot forward or backward, left or right. So as always, the other videos are up on YouTube if you want to watch them. Leave a comment, like, and subscribe if this helped you. And thank you so much for watching. Have a nice day. Goodbye.